Meron tayong ditong bagong pyesa, SN74LS04N IC, diba? Siya ay 14 pins. 14 pins siya. Ano na naman yan, tutoy? Ay, meron tayo bagong pyesa. Ito. Ay, para saan yan? Ito? Ay, gawa tayo ng bagong project. Ito ay tinatawag na NOT gate o yung tinatawag na inverter gate. Ano namang gate yan? Pintuan ba yan? Ba't may gate? Ay, pag gate, ginagamit ito sa pagdidesign ng circuit. O pwede rin sabihin natin ito ay switch. O, diba? Ini-invert niya yung kanyang output. Paano yun? Ba? Lagay natin sa circuit. Testingin natin. Ito na ang ating project. Meron tayo dito switch. Push button switch. Normally open. Okay? Ito, breadboard yan, di ba? Jumper wires. At saka integrated circuit na 7404. At itong LED module. LED module yan, ginawa ko. Okay? Siya ay umiilaw na, di ba? Yan naman ang gagawin mo dyan. Makikita mo rito kung paano ako mag-magic. Magic na naman. Aba? Ako ang pinakamagaling na electronics magician sa Pilipinas. Anong magic yan? Pag pinindot ko yung switch, di ba, nakailaw yan. Normally, on na siya. Pag pinindot ko yung switch, nawawala yung ilaw. Di ba? Pag nirelease ko, may ilaw na naman. Isa pa. Pindot, walang ilaw. Release, may ilaw. Yan ang aking magic. Ay, tutoy. Walang kwenta na naman yung magic mong yan eh. Ayaw mo? Isa pa. May ilaw? Pag pinindot ko, nawawala ang ilaw. Yan ang magic talaga. Wala ngang kwenta yan. Aba? Ano ba umiilaw siya? Tapos nawawala? Diba? This is now our NOT gate 74LS04 actual circuit diagram. Okay? And this is the IC 74LS74 04 with the 14 pins. 1, 2, 3, 4, 5 up to 14. Pin number 1 is input, 2 output. So we have a switch here. Switch 1, then our supply is 5 volts. The ground, pin number 7. And into the pin number 2, we are having this LED output R1 of 330 ohms and LED blue. If this is our IC, we have the inside circuit or circuitry. In our IC, inside is composed of 6 inverters. Inverter 1, 2, 3, 4, 5, 6. Okay? And we have this NOT gate inverter gate symbol. Okay? So inside the IC of 74LS04 is a NOT gate. So pin 1, as we have seen here, is an input. Pin 2, output. 3, input, output, input, output, then ground. Output, input, output, input, output, input, then VCC, 5 volts. Okay, this is the symbol. While we are in the digital electronics subject, we need to use a truth table for the 74LS04. It has a truth table of input A and then Y, the output. So whenever the input is 0 or logic level low, okay, there's no voltage here, it will invert the low into high, becomes 1. And when you have a input of high level 1 into the output, it will invert the output into 0. So 0 to 1, 1, 0. Okay, that is the truth table. This is now the schematic diagram for our 74LS04 NOT gate. So here, the same switch, 5 volts, and then we are only using one inverter gate. So inside the IC, we are only using single inverter, U1, which means an inverter unit 1 just using only 1 out of 6 inverter. And then into the input, which is pin number 1, this one, and then to the output, pin number 2. Okay, that's why we connected the LED, which is the output. So initially, our circuit or the LED turns on, so it is on without pressing the switch, because our signal is, or our input is 0. As we have seen here, if the input is 0, it will invert the output into 1. What do I mean by 0? That is a high level voltage or equivalent to 5 volts. And then, 0 volts. It's a low level, 0 volts. And then 1, 5 volts. Okay? So 0 here, when there's no voltage or low level voltage. For this type of IC, the low level voltage is, I think, 0.8 volts or lower. So if the voltage here is 0.8 volts, it is considered as low level or 0 up to 0 volts. So if this is low level, equivalent to 0, logic level, logic 0. And then passing through the inverter, it will invert the input into 1. And then for the logic level 1, which is equivalent to 5 volts, starting from 2 volts to 5 volts. So 2 volts in the input is equivalent to logic level 1 or high level, or it is on. And logic level 0 is equivalent to 0 volts up to 0.8 volts. Higher than 0.8 volts, 0.8 between 2 volts to 0.8 volts. That is indeterminate, or it is some sort of there's a noise. You cannot tell it whether the circuit is on or off between 2 volts to 0.8 volts, because 2 volts is considered as high level logic, and this one is low level logic, 0.8. So between 2 and 0.8 volts, we cannot determine whether it is on or off. So logic level 0 referring to off, or a voltage level of 0.8 volts in the case of this IC, and 1 starting from 2 volts up to 5 volts. So low level starting from 0.8 volts up to 0 volts. That is the equivalent voltage for this IC. So when I press this switch, it becomes logic level high, or 1, sending a 5 volts to the input of the inverter, and then passing through this circuit or this inverter gate. The logic level high will invert it into low, 0 volts, or low, or 0.8 volts up to 0 volts. So LED will turn off. Initially, if this is 0, no input signal or no input, this is high, 1, logic level 1. It means there is a voltage here equivalent to, if the LED turns on, I think it's 2 volts. There's a 2 volts up to 5 volts if this is on. And when I press the switch, it will turn up the LED. For the final circuit of SN74LS04N NOT gate module, I'm using this diagram. So I added the power LED, which is colored red LED, SMD type 1206 LED, and SMD type 3K resistor for the power LED. It is just an indicator. And then I added the input LED. So whenever I press the switch, this LED turns on. If this is on, which means I press the switch, the output LED is off because it is inverted, or it is inverter. So when I did not push the switch, this LED turns off because the switch is not active and the output is on, or LED color blue is on, blue color. So when I press it, it will turn on and this output LED turns off. And I use this module. This is now the main module with pin header, with some patching. You need to patch the input, output. This is my design. You need to patch the input, output, and the switch